Okay, so we're going to start by using an example of substitution. Now, what you see with this one is that we have this, the second equation says x equals. And whenever you have one of your equations that's either x equals or y equals, that's the indication that it's a good choice for substitution. So, and what we're going to do is we're going to take this second equation and we're going to plug it into the first equation. So we're going to take our first equation and I'm going to rewrite it down here. But instead of the x, I'm going to put a parenthesis. Because what I'm going to do is where that x is, I'm going to put in what my second equation says that x is equal to. So I'm going to put in 2y plus 6. Okay. Now we have an equation with just y in it. And now that we have just one variable in the equation, now we can go in and solve for y. So let's do that. So I'm going to multiply the 2 into the parentheses. I'm going to distribute it. So I have 4y plus 12 plus y equals 7. And then let's combine like terms. So the 4y and the y, so that's going to be 5y plus 12 equals 7. Now let's subtract 12 from both sides. So 5y equals negative 5. Divide both sides by 5. And you get y equals negative 1. Okay. Any questions there? Okay. So now what we do is we're just going to take this negative y equals negative 1 and plug it back into one of the equations so that we can find out what x equals. Well, in this case, it's easiest to use that second equation. So x equals 2y plus 6. In place of the y, put negative 1. So what is that? Negative 2 plus 6. So x equals 4. Then it's always good practice to check it. So I used the second equation to come up with what x equals. If I plug that y equals negative 1 and x equals 4 back into that first equation, then we can check it and see if what we have makes sense. So let's see, what's that? That's 8 plus negative 1. Well, 8 plus negative 1 is positive 7. So that means it checks for us. Okay, any questions there? Okay, so this method, like I said, is best used when you have just like x equals and you can plug it in for x, or you have something that says y equals and you can take that and plug it in for x. Okay? Okay to go ahead and switch this page? Okay, I don't have enough room to do another problem. Okay, next problem. I'm going to go to solve by elimination now. So something like x plus 4y equals 2, 2x plus 5y equals negative 2. So this method, this elimination method, means kind of what we're going to do is add the equations together to eliminate one of the variables. So don't write this down yet. Just watch me. Don't write it down. There's a reason I'm in pencil. I'm going to erase it. So if I just add these together, then I get, because there's a 1 here, I get 3x plus 9y equals 0. Right? Did one of my variables eliminate? No. They're both still there. So sometimes your first step can be just to add these together like this, but not this case. We actually have to multiply one of the equations through by something to create the coefficients that are opposite signs so that they will eliminate. So like on the first one, if I take this equation and multiply it by negative 2, then this term right here, the first one's going to be negative 2x and the second one's going to be positive 2x. So when I add those, they would eliminate. So I'm going to go ahead and distribute this negative 2 to every term. Now let's go ahead and add them together. So the x's cancel themselves out. And I'll have negative 3y equals negative 6. Divide both sides by negative 3. So we're going to get y equals 2. Then to find out what x is, take one of the equations, it doesn't matter which one, and then plug the y in for the y value. So we get x equals negative 6. And then just like I did last time, let's go ahead and take those two values and plug them into the equation that we did not use to solve for x. So 2x plus 5y equals negative 2. Plug the negative 6 in for the x. And the 2 in place of the y. And it does end up checking there. Now the one thing I forgot to do on the last one is when you put these answers in, we put them in as an ordered pair. So we put them in as the x value first, the y value second. So the answer, the solution here is the point negative 6, 2.